Hello, today we're going to be reviewing how to write the electron configuration, the noble gas configuration, and the orbital diagrams of elements. So, for example, we're going to start with sodium. To start, always find the number of electrons each element has. So we'll look on the periodic table, find sodium, and since it has the atomic number of 11, the atomic number equals the number of protons. So 11 protons, and the protons equal electrons, so 11 electrons. We'll use this to find the electron configuration. The electron configuration is, this shows where the electrons are located. So we have to use the Aufbau principle, which tells us the order in which orbitals are filled. So it goes to 1s, then 2s, 2p to 3s, 3p to 4s, and so on. So since it starts with 1s, we'll write 1s. And then remember, 2 electrons can fill each sublevel, so we have 2. And then we'll go to 2s. Again, 2 electrons, 2p. Remember, this can be 6, have 6 max electrons. But then we'll stop there for now. So we'll count the number of electrons. So we have 2 electrons plus 2 electrons plus 6 electrons. So that's 10. So we have 10 electrons. We need 11. So we need 1 more. So then we'll go to the next sublevel, 2p to 3s, but we only need 1. So while the s orbital can have 2 electrons, we only need 1. So we'll just stop at 1. So when you add the superscripts of your electron configuration, this should equal the number of electrons the element has. In order to find the noble gas configuration, which is just a simplified version, you need to find the element once again, go to the row above, and find the noble gas in 8a. So for example, sodium is over here. We need to find neon. So we'll go to neon. So write the noble gas. But remember, neon only has 10 electrons. So this only represents 10 of the 11 electrons we need. So we still need 1 electron. So we'll go up to here, and remember this 3s is the excess. Remember, because this is the electron configuration for neon, but we need sodium, so we'll add the 3s. In order to draw the orbital diagram, which shows the distribution and spin of the electrons, we need to use the orbitals and sublevels. So we're just going to take this electron configuration. We first have s. So remember, s has 1 orbital, so 1 box. And then we'll label that 1s, that's to 2s, again, just 1 box. 2p. 2p has 3 orbitals, so we'll write, we'll make a box with 3 boxes inside it. Then we'll go to 3s. 3s is 1 orbital again, so we'll have 1. Okay, so now that you can see the boxes, we'll have to use both the Pauli exclusion principle and Hund's rule. So first with the Pauli exclusion principle, we'll have to, in each box, in each orbital, there needs to be 2 electrons with opposite spins. So for example, we'll have 1 going up and 1 going down. So this is how you correctly write the arrows in an orbital. And this represents 2 electrons, 1 plus 2 electrons. In the 2s, we do the same thing, 1 electron, 2 electron. And in the 2p, well, this is where Hund's rule comes, or the bus seat rule. And remember, each electron has to singly occupy each orbital, so before they can double up. So first, we're gonna, from left to right, have 1, and remember, we can't write this, write the second electron in this box. It has to be in the next one. 2, 3, and then next you can finally draw the rest. And so now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. But remember, we need 11, so we still need this 1. So then we'll draw 1 going up and then leave the rest blank, because now we have 11 electrons. So go ahead and try the electron configuration, the noble gas configuration, and the orbital diagram for copper, and we'll see how you did. Okay, this is the completed electron configuration, noble gas configuration, and orbital diagram of copper. So I found that there were 29 electrons. I found this by finding copper on the periodic table. It has an atomic number of 29, so 29 electrons. I found that it is 1s, 2s, 2p, and so on by using the Aufbau principle and using the arrows. I filled all of these in except for the last one, because I realized that while the 3D sublevel can have 10 maximum electrons, I only needed 9 to get to 29, because 2 plus 2 plus 6 plus 2 plus 6 plus 2 plus 9 is equal to 29 electrons. In order to find the noble gas configuration, which was argon, I found copper on the periodic table, went up a row, and found the noble gas, which was argon. But remember, argon only has 18 electrons, and we need 29. So then I found out that argon represents these electrons, but the 4s2 and 3d9 are needed on the end. In order to find the orbital diagram, I drew out all of the boxes. Remember, it's 1 box for S, 3 for P, 3 for D. If we needed F, it would be 7, and remember, this is based on the number of orbitals. In order to do 3D, I did up arrows first for all of them, because remember, this is in accordance to the Hund's rule or the Bussey rule, and then I went and did the opposite spin per the Pauli exclusion principle. So I hope this helped. I hope you understand this better, and good luck on your test.